Hello, and thanks for using TickBoom. In this question, we're being asked to differentiate the function of x that you see here on the screen. So let's just dive in and give it a crack. Okay, so for this question, we're being asked to differentiate the function in x that is equal to 7x times the square root of x minus 8, all of that divided by the square root of x. And so we're going to have to apply a few rules of differentiation. The first rule that jumps out at me looking at this function is the quotient rule. And the reason for that is because my function involves one thing divided by another. So what I can do to help with applying that rule is I can say our function is equal to f on g, where in this case f is equal to the numerator, 7x to the square root of x minus 8, which we can simplify a little because we know that the square root of x is the same as x to the power of a half. When you have x to the power of something times x to the power of something else, you can add up those exponents. So we'll get 7 times x to the power of 1 plus a half is 1.5, or 3 on 2, minus 8. We get g as the denominator, which is the square root of x, which again I'll just write as x to the power of a half, because that will make it easier to apply our other rules of differentiation. And once you know that, once you've laid it out in that form, you can then apply the quotient rule, which we know as f dash x, or the first derivative of x, is equal to, and using this notation, we can write the quotient rule as f dash g minus g dash f, and all of that gets divided by g squared. So what that means is f dash is the first derivative of f, g dash is the first derivative of g, and g squared. So that's the quotient rule. Now in this video I won't go into the detail of why the quotient rule is true. When it comes to exams, this is really just something you need to know off by heart. You take it as a given. So that's what I'll do here. So now the task really just becomes working out the first derivative of f and the first derivative of g and g squared. And once we have all those ingredients, we can work out our derivative. So what I'll do is over here, we'll first work out the first derivative of f, and that will involve us using the power rule. So one of those most basic rules of differentiation. The power rule basically says if you have a function, you bring the exponent down in front and then you subtract 1 from the exponent. So for f dash we'll get 7 times, bring the 3 on 2 down, times x to the power of 3 on 2 minus 1, which gets us a half. And then the 8 disappears because that's essentially 8 times x to the power of 0. And when you bring the 0 down, you're multiplying by 0, which gets you nothing. So that's f dash, which we could then write as equal to 7 times 3 is 21, divided by 2, x to the half. So there we have our f dash. Now we'll work out g dash. And here we'll bring the half down, times x to the power of half minus 1 is negative a half. So that's g dash. And we also need to know g squared, which is equal to x to the half to the power of 2, which just gets you back to x. The square root of x squared gets you back to x. So there we have our ingredients that we need to complete our quotient rule. So now we can just insert them all and then simplify using algebra. So what we'll get is f dash x is equal to f dash, which is 21 on 2 x to the half, times g, which is x to the half, minus g dash, which is a half, x to the negative a half, times f, which is our 7x to the 3 on 2 minus 8. And all of that needs to be divided by g squared, which is x. So that's the first derivative. Now we just need to simplify it using classic algebra. So what we can do first with this numerator, over on this bit, x to the something times x to the something, you can bring those together and just add up the exponents. So we'll get 21 on 2, half plus a half is 1, so times x. And here what I'll do is, over in this part we've got x to the minus a half, which is the same as dividing by x to the half. So we'll say minus, and we'll have what's on our numerator, which is 7x to the 3 on 2 minus 8. And all of that is divided by 2x to the half. So that's our numerator, and then that is still divided by x. And now what we can do to simplify this is we can divide each part by x. So over here, 21 on 2 times x divided by x, the x will just cancel out, so we'll get 21 on 2. And over here, we'll keep our numerator, and this x essentially just comes up here. So we get x to the half times x to the 1. You get to add up those exponents, so we'll have minus 7x to the 3 on 2 minus 8 divided by 2x to the 3 on 2. Half plus 1 is 1.5, or 3 on 2. Now we can simplify this a little further. We'll get equal to 21 on 2. Now in this case, the x to the 3 on 2 cancels out with the denominator x to the 3 on 2. So we'll get minus 7 on 2. And now we'll expand this bit. Minus times minus 8 gives us plus 8 divided by 2x to the 3 on 2. And the last step to simplify that, 21 on 2 minus 7 on 2 is 14 on 2. 14 on 2 is 7. Plus, and then 8 divided by 2 is 4. 4 on x to the 3 on 2. And that there is probably where you can stop. That's as simplified as you can get it. So there is your first derivative. Now there is a way you can check whether you've made any mistakes here, and that's by using the product rule, because whilst our function here is one thing divided by another, you could also rewrite it as one thing multiplied by another and then use the product rule of differentiation and see whether you get the same answer. So I might just do that as a test. So let's come over and rewrite our function fx as equal to 7x square root of x minus 8. That's still the same as before. But instead of dividing by the square root of x, we'll multiply by x to the negative a half. That is essentially the same as dividing by the square root of x, but now we've got one number multiplied by another, or in other words, f times g. And when we've got two things multiplied by each other, our product rule, f dash x, says that the derivative will be equal to f g dash plus f dash g. And again, just like the quotient rule, that's something you commit to memory. I won't go about trying to prove that now. But again, we take a similar approach. We just need our ingredients, and then we can insert them all and work out the derivative. So in our case, f is still the same as what it was before, and I'll write it in that simplified notation. So we get 7x to the 3 on 2 minus 8. G in this case is x to the minus a half. F dash is going to be the same as what we got before, which will be 7 times 3 on 2x to the half, and the 8 disappears, which gets us 21 on 2x to the half. And then g dash will be equal to minus a half x to the minus 3 on 2. So now we can insert these up into our product rule. So f 7x to the 3 on 2 minus 8 times g dash, which is negative a half x to the minus 3 on 2 plus f dash, which is 21 on 2 x to the half times g, which is x to the minus half. And now we'll simplify that. So we'll get equals to, and right away I can see this x to the half and x to the minus half will cancel, leaving us with 21 on 2, and I'll just write that first, 21 divided by 2, and then we'll get minus, and we'll write our numerator, 7x to the 3 on 2 minus 8 divided by, and because this is a negative we can bring it into the denominator, 2x to the 3 on 2. Now hopefully that actually looks familiar, because that is exactly the same as what we got to here. So we know that that will simplify down to that, which means we can probably just skip a step and we can know that we're going to get to the same place, which is the 7 plus the 4 on x to the 3 on 2, giving us the same result for the derivative, which gives some level of comfort that we haven't made a mistake in applying these rules. And that is always a risk with this kind of differentiation stuff. You can memorize the rule, but just make a little mistake somewhere along the way with your simplifying and end up with the wrong thing. So whenever you can, it's always handy to have a way to check your work, especially if you're doing this on an exam, you find yourself with a bit of extra time at the end. It's always helpful to have ways to double check that you haven't made mistakes, because that's going to end up being the difference between those who get the best marks and those who get good marks. You may know the same amount of math, but it's whether you can have the discipline and the techniques to check that you don't make mistakes. It's those silly mistakes that end up being the difference between who might come first in a subject and who might come second. So hopefully you found that helpful, and that makes it clear how you can go about differentiating something that at first glance may look, like it might not be obvious how to go about it. It's really just thinking, what rule can I apply to help me here? And in this case, it was either the quotient rule or the product rule. All right, tick boom.